Okay. Let's see. Let's talk about, is that it? So there's really no notes for this because you're doing the same thing. So let's just look at the problems. It says, find the area, how's it stated, of the region bounded by the graphs of y equals 16x, y equals x to the fifth, x equals 0, x equals 2. So when you go to your calculator, and this is what I want you to do, I want you to go to your calculator and in y1 put 16x. In y2 put x to the fifth. You can't put in x equals 0 or x equals 2. We just need to know what that looks like. Those are vertical lines. So put those two guys in, and you should get something like this. Zoom 6 is a basic screen. Sometimes that'll work for you, sometimes not so much. I don't know. Does it work that way? Can you get that picture if you do a Zoom 6? Anybody? Okay. So you want to sketch that on your paper. And you want to note that on this side is the 16x, and this side is the x to the fifth. Okay, because it's going to matter which one is on top. Okay? All right, then I noted that here's x equals 0. That's that line. And here's x equals 2. Okay? So what you're going to do is the area of that region is the integral from 0 to 2, from 0 to 2, of 16x minus x to the fifth. 16x is first because it's on top. Whatever's on top is the first one, and you're subtracting the one on bottom. So you would sketch the picture and then write this integral. The area is the integral from 0 to 2 of 16x minus x to the fifth. Questions on how to put that down there?
Do we need to put the x equals 0 and x equal 2 in order to get them?
Well, those are your limits of integration. You can't put it in the calculator because you can't put an x equals.
I don't get that.
You don't, which part, Jason? You don't get that picture?
Get that picture.
Did you put in these two like this?
I have y equals 16x and y2 is x to the fifth.
And do a Zoom 6. Do you have it? It's thinking. That's okay.
I'll just keep a little bit.
Okay.
Because I had it above it a lot.
Okay. Meg, look at his and see if you can see anything different than what you had. The next part of that is just doing the integration. 16x becomes 16x squared over 2 minus x to the sixth over 6 evaluated 0 to 2. So we're doing the same thing that we've been doing, the integration. Okay. And then you're just going to plug in the 2. Did that work?
Yeah, I just glance up below the line.
Okay.
In the corner.
Okay. All right, so you're plugging in 2, and you ultimately get 128 over 6, which reduces to 64 over 3. And that would be the answer. That's the area of that region between those two graphs. So your steps, you want to put those in your y equals, get a picture of the graph. If the limits are given to you, great. If not, we're going to have to find some intersection points. And I think we have to do that on the next problem. So. Everybody okay? On the next one, it says find the area of the region bounded by the graphs, and it gives you two graphs, but it doesn't give you any x equals. So we don't know the limits. We have to find the limits of integration. So they gave you 2x plus 24 and y equals x squared. So that's your y1 equals 2x plus 24 and y2 equals x squared. And I put a window here for you so you could see it. You might have to manipulate that yourself if I weren't helping you. But this is your x min, your x max, your y min, your y max. So here's x min, not to be confused with Wolverine. Okay, x max, y min, and y max. So if you put that in as your window, you should get a good picture of this graph. It should look something like this. Except you don't have x equals 6 and x equals -4 on your graph. How are we going to find those? Intersect. So you're going to do second calc 5 and get your cursor close to one of these points and hit enter 3 times. That's the algebra of this. And then you're going to repeat it, second calc 5, and you're going to move over to this guy and hit enter 3 times. You should be able to get -4 and +6. Try that. Make sure you can get those intersection points. Everybody able to get those intersection points? Because you need those. Those are your limits of integration. Because we're going to integrate from -4 to 6, and that won't be given to you. You have to figure those out. Now, why do I have 2x plus 24 here instead of here? Why isn't it reversed? Because the 2x minus 24, the straight line is on top. So it goes first minus this part of the graph, which is x squared. So you've got your two pieces of the graph, subtracting, and you get that, and you're doing this evaluation. So then you do your integration. The integral of 2x is 2x squared over 2. Integral of 24 is 24x. Integral of this is x cubed over 3. This one we don't have a 0, so we got to plug in 6 for all that. We got to plug in -4 for all that and do the subtraction. I did it in 2 lines. If you plug in +6, you get this, 108. If you plug in -4, you get -58 2/3. And you ultimately, you have minus a negative, so you're actually adding, and you get 166 2/3. Does anybody have their laptop in here? No. For some reason I have 3 and 4 marked out. I know you're really sad on that one. Are there just 5? Wow. You can tell it's the end of the road here. Okay. Any questions on that one? All right. Y equals e to the x. We're skipping to 5. Y equals e to the x. Y equals negative 5x squared minus 6x. You'll want to put those in the calculator and know that this is the parabola. Here's the y equals e to the x. Okay? We don't know the limits of integration, so you're going to have to find those. How do you find them? Second Calc 5 and get them. You're going to get decimal limits. Double check that you get these two numbers for the left side and the right side. Anybody get those? Anybody trying to get those? Lee, did you get them? Mm-hmm. You got to be able to get those kinds of limits, because even if you're doing a Math 9, you've got to have those before you can put it in Math 9. Which function's going to be on top? You did get them. Which one's going to be on top? The parabola. So we've got, here's your function. The integral from this left number is going at the bottom. I don't have it written there. And up to negative 0.164 of this guy minus e to the x. Okay? Once you get that, you can do it on a Math 9. So let's try and get the final answer. You're going to do Math 9. You're going to put this in comma x, comma this number, this one, and then this one. Here it is, how to put it in. At the bottom is how to put it in the calculator. So make sure you can put it in, and let's see if you can get 0.827. Did you get it? Okay, so the thing that you really have to do on this kind of problem, I'm not asking you to do this one out by hand, but you do need to be able to put it in the calculator, get a little sketch, find the left side, the right side, where they intersect. Those are your limits. And that allows you to have this and this. You need to know which one's on top, so you had to sketch it to do that. Any questions?